So without further ado, I'd like to introduce Adrian from Societe Generale, David Chung from Docker, and Laurent from Sogeti. We also had one more speaker, but unfortunately he fell sick, Ludwig Piot, but he's also contributed to this project and to this talk as well, so we definitely want to give him a shout out as well. Cool. All right, so without further ado, I will hand it over to Adrian and Laurent, and they can take it away and have a duel with Skynet and Planet of the Apes.
Maybe we have the slides. Maybe easier. Okay. Well, thank you for coming to this talk. Today, the idea is to explore some various topics around Docker, not to get deeply into one or another topic, but have a broad approach of a lot of projects and work on which Docker is working on. The idea today is to discuss automation, hybridization, multi-architectures, etc., through a fantasy, because we are at the Docker conference. It's much more fun if we have a kind of metaphor to express what we want to present. Well, you are spoiling. Yeah.
Okay, so here's the slides.
Great. So, the idea is to express that this platform that we will discuss about for the next few minutes will be Skynet. And since Skynet has some offenders, we decided to use the Apes metaphor to leverage on Chaos Monkeys to attack this Skynet platform. And the question is, will the Skynet platform will resist against the attacks of the Apes? First of all, our Skynet platform is obviously completely independent from everything. So the idea was to make something agnostic, completely independent from the offers provided by the vendors. Of course, Azure, AWS, Google are providing their own solutions bundled and ready to use. But here, the idea is to create your own stack, leveraging on several vendors, and of course, also, if you want, on your own data centers. Because this scenario is interesting because it may help for migration scenarios, it may help for elasticity when you want to extend your original DC over additional capacities provided by these vendors. But it may also provide some new interesting use cases. For example, we could discuss cloud arbitration, because I'm working for a bank, and I was thinking that if you are able to deal with several cloud vendors, you may want to arbitrate where you want to use your capacity, and to adapt the vendor you use to the cost and the pricing model of your vendors on the fly. This is completely not new. The idea was just to remind that since Docker 1.12, every Docker cluster operation is secured by design. But I just wanted to remind that the communication of the overlay networks should be explicitly encrypted. And since the Skynet is a closed box which is hosting its application and which will be attacked, the idea is to get it completely secured, obviously.
Okay, so Adrian talked about Docker Swarm. So first of all, we have to provision this cluster. So we're going to use a Docker project called Infrakit, which the main contributor is David Chung on stage here. And we went through some stages to start up this cluster. So first of all, we have a Bootstrap node that runs with CloudFormation for AWS, but you can use also ARM for Azure or Terraform for Cloud Agnostic. Once this Bootstrap node is starting up, you start Docker images with Infrakit to check the desired state of the swarm, and it does some bunch of things. First of all, it gets static assets from a URL, for example, JSON files containing all the desired state of the cluster. And then it checks the groups.json it's the main entry point of the cluster, of the desired state, and then they deep dive into the group.json to find different plugins, AWS, GCP, which will be demonstrated further. And then we have some manager and worker.json files which define how to boot the manager and the worker, and how to initiate some scripts to install Docker, to have Docker some join, to have some volumes, for example, and a lot of stuff. And finally, you deploy the Skynet script to start up the Skynet cluster. As a reminder, you also can have of Raspberry Pi, so IoT devices. You can start an experimental feature. So basically, you just type Infrakit X remote boot, and it starts up a DHCP server, an iPXE, and a TFTP server, and you can launch any images you want. For example, you can launch a LinuxKit image to have some kind of immutable OS. I will digress a little bit and focus on the selector plugin. So a selector plugin is one of the plugins of Infrakit, and it can leverage on multi-cloud. So here we are going to use AWS and GCP, and it takes care of the resilience of the cluster at the node levels. So it boots up and scale up and scale down the nodes at the cluster when as the cluster goes. So you basically take care of the resiliency of the cluster at the node level, at the infrastructure level. So here is an example of a JSON file which contains two plugins, so AWS and GCP, and which use the selector plugin. And we have three types of selector. We have spread, we have weighted, and we have tired. So here spread is 50-50 between AWS and GCP, but you also kind of weight the selection between AWS and GCP, for example, 80-20%. Here is 50-50. And of course, you describe what region you want to have the nodes, what type of nodes. For example, AWS is T2 micro in EU Central, and on GCP it's N1 standard on EU Central 2. So now we have a cluster, a Swarm cluster, which is booted up, and as the apes attack us, we want the cluster to be able to self-heal himself. So Infrakit constantly monitor the desired state of the cluster and boots up some nodes as they are terminated by the apes attack.
Okay, so thank you, Laurent. At this stage, we have built a cluster which is made of capacities which are hosted on several cloud vendors, and everything has been provisioned using Infrakit tools. Infrakit is also providing some self-healing capacities, since you are describing in it the desired state. If you remove a node, or if you lose some parts of the topology, it will recreate and make the cluster up again with all the capacities requested. But what is important here to say is we are discussing the resiliency and the scalability of the cluster itself. This not be confused with the containers and services scalability and resiliency model. Containers are managed through the orchestrator of Swarm, and this is Swarm which is responsible to deploy the containers, run it, to respawn new containers if some instances have been lost. Here we are discussing at a lower level. If you are missing a server, then the Infrakit will be responsible to spawning again some new servers. So this is two different stages of orchestration and of resiliency capacities. What is important to say also is whether we are discussing the Swarm orchestration or what Infrakit is doing to self-heal the cluster itself, The thing is, you must create applications which are built for this kind of resiliency and scalability, because these orchestrators are just built to respawn the resources, to respawn container instances. The thing is, if your application is not built to support this kind of resiliency, it won't work. Because, for instance, if your application have some cache effect, if it's stateful, if it embeds some kind of data, etc., etc., the risk is you will lose a lot of information related to your application, and when you will scale up or down, your application will not work correctly anymore. So scaling and self-healing is not just about having the capacity to spawn up or down the appropriate containers and cluster nodes. The thing is, the application must embed logic to support this kind of way of achieving the scalability and the resilience.
Thank you, Adrian. So now we have a cluster set it up and self-healed by Infrakit, and we want Apes to destroy these nodes and try to destroy this cluster. So we originally worked with the Netflix Chaos Monkey. So Netflix Chaos Monkey is a little program which killed nodes from time to time directly on AWS, but it's not suited for this demo because it's built for production. And it's not suited for a demo. It only kills instances every 24 hours or more, and it's tightly coupled with target application delivery tool called Spinnaker. Spinnaker is an open source software designed by Netflix to have continuous delivery production grade. So we have built our own Chaos Monkey that kills nodes every 3 minutes on the cluster, to demonstrate you the power of Infrakit and the resiliency of the cluster. And of course, it's packaged in a Docker image. So now, enough talk, and I will switch to the demo. And I don't pray the God of the demo, but maybe it will work. Okay, so I have to show you the cluster. So the cluster here is on AWS. We have 5 nodes. We have the Bootstrap node, which is the first to be launched. And then we have 2 workers and 2 managers because I designed the cluster to be 5 nodes. And then we have another node. So we have all the 5 nodes here. So on AWS. The instance 1 and instance 2 are on GCP, so it's a little bit more powerful. And then we have some Pi to demonstrate you multi-architecture cluster. So Swarm can leverage also on another architecture that x86. So we have our cluster, which is 3 managers and 6 workers. So we have 9 nodes, and we're gonna launch some Chaos Monkey. So I will launch the Chaos Monkey because it takes about 3 minutes to kill 1 node, and then I explain what I do. So here I basically launch the Docker image that kills nodes every 3 minutes. Everyone is... Do you see well? Yeah? Cool. And then about 3 minutes later, it will kill a node randomly on the cluster, and Infrakit will self-heal the cluster. So basically, what we are doing here is the Terminator script. So I terminate instance in random on AWS, and then kill the instance. We terminate the instance randomly every 3 minutes. So you have the sleep 180 here. And Infrakit will see the desired state, which is not the same as the before, and then reboot a node, reset a node, reopen a node. So how does Infrakit work? So I told you that it takes some static files. So here is a main entry point. It's a grabs.json file, which source little bits of script. So basically, it only takes some parts of the variables and declare variables. So for example, the swarm leader, the manager IPs, etc., and create a bigger JSON file, which is the desired state of the cluster. So here we have a first plugin, which is a manager, and we see that we use the plugin group. So we create a group of manager. We give them a logical ID, so managers, and here we use a flavor that is swarm manager, which is a bunch of scripts that say, here is my manager IP1, IP2, IP3, here is init script template file, and here is a leader IP's address. And every time a node boots, it basically starts a Docker Swarm join with the IP and the token. And here is another group. So this is a group of workers. And we have some Swarm worker plugin, and it's basically the same. So when we start a node, you can split your scripts with little scripts to start whatever you need, and you can parameterize the scripts. So, for example, here we have some Docker Swarm mode. If the swarm is not initialized, the script launch a Docker Swarm init, which initializes the Docker Swarm and created the token, and then it will put the token on a key value store backed by Swarm, and every time a new node starts, it basically say Docker Swarm join with the token described. So we're gonna see if the cluster has been killed. Not yet. So the Skynet here in the it has been killed. So if I go back to the AWS, basically it shut down the bootstrap node. So this is the first one. So it's completely random, and then you will see that Infrakit take care of this node which are being terminated, and then bootstrap a new node. So it may take some time, about 1 or 2 minutes, and then it bootstrap a new node. So the bootstrap node is basically a manager, so it restarts a manager. And then here we have, as I told you, the multi.json. So it's basically a file that spread the nodes between GCP and AWS. So it's basically what I demonstrated you earlier. So you have 2 instances here, AWS EC2 and GCP Compute. And Infrakit take care of that automatically. So now you've seen that the bootstrap node has been terminated. So it's completely destroyed. And Infrakit Skynet Manager are booting up because Infrakit takes care of that on its own. So it's basically sees the cluster is missing a node and restarts a manager because it's a manager that are being destroyed.
Okay, thank you. Now we'll discuss how these nodes are being built. Infrakit is here to orchestrate the provisioning and the self-healing, as you showed just before, of this cluster of resources. Historically, we used traditional universal Linux distribution operating systems to install Docker and some stuff to make our cluster workings. But the question is, since the nodes of our cluster are just intended to run to run Docker agents contributing to this cluster, the question is, why do we need such large, huge operating system? It has a large surface attacks because it embeds a lot of things. And the point is to build on-purpose operating systems which are just designed, which are tailored just to embed the Docker engine daemon and everything requested to make this Docker daemon running. The second thing is it's not just a question of size, it's also a question of immutability. The idea is patching, upgrading, managing operating systems. It takes time, it costs a lot, it's complex. So the idea is no longer to have this kind of management. Is like for software. It's just about building up an operating system image dedicated to the role we want it has to have, being just a node of our cluster. And if we need to upgrade something, upgrade Docker, for instance, we no longer want to update something. We just want to rebuild a new image like we do for the containers. So we just want to rebuild a new operating system image and deliver it. And we may, for instance, roll the deployment of the new instances of these nodes and remove the older ones. So it's no longer necessary to update everything and have some mess with this kind of traditional patch management systems. And for this, we are using LinuxKit, which is intended to build these on-purpose operating systems.
Okay, so basically what we are doing is created a LinuxKit.yaml file with Docker inside. So it's a package named Docker. For example, it's 17.09 here. We built the LinuxKit image with Moby, another tool from Docker. So you basically just say Moby build my image, my immutable image, and then you push it on every cloud provider. So here is AWS, and you can push it on Azure, on GCP, or whatever. And you repeat the steps for every cloud provider you want, and every time the image will change. And then you basically start the AMI image on each cloud provider, and you have a metadata package, for example, for the cloud provider to get the key from the metadata and write it at boot start. So basically, you have an image with the SSH key to be able to SSH on the image and do some work. But there's some little drawbacks. We cannot use Cloud Init due to LinuxKit immutable nature. So the question is, how can we inject the manager IP address and the joint token? So basically, you have three options. Bake the token in the LinuxKit image, but it's not secure by default because everyone can start a node on your with your privilege. The second one is to expose the token with Infrakit util file server, and then basically do a Docker swarm with the token grep from the URL, or create the third option is, I think it's a better one, create a Cloud Init package style for LinuxKit. So it's a little drawbacks.
Okay. Now we have been able to create a cluster provisioned automatically with Infrakit. All nodes composing this cluster has been created as minimalist operating systems and immutable ones. And all of this remains on the cloud for the moment, okay, on several cloud vendors, since we want to be agnostic and be independent of these vendors. But the thing is, it's still traditional architectures. And it's about hosting containers for Linux. You all know, I think, that Windows is now proposing Docker containers as well, and Hyper-V containers also. But that's not all. There is also the containers for ARM, which has been delivered for some time now. And these architectures will tend to be more and more used in the future. I remind a few hours ago during during the keynote, I remind that the Docker CEO discussed some industrial use cases exposing IoT and everything which are far beyond just the cloud. And so getting outside the cloud will probably imply to have and support more and more devices using this kind of architectures. And so, if you want to manage these devices and work more globally in your data, in your topology, you will have to create some hybrid clusters which will host traditional nodes which are on the cloud, but also external nodes which may be on physical devices, on a Raspberry Pis for testing, or IoT devices, and all of these will compose a kind of cluster. And this is the beginning of the edge computing, because you no longer just centralize everything in huge data centers. You decentralize parts of the computing, part of the operation, part of the application on the remote devices which are part of this cluster. But let's get back on Skynet. Our platform was made of cloud capabilities. We just said this before, but we added some Raspberry Pi devices as well, and we integrated these in the cluster. The idea is that our Raspberry Pis are a kind of metaphor of our terminators. It represents the device which has some kind of sensors enabling to detect movements and these kind of things, and which can have some actions. And we do this using the GPIO ports of the Raspberry Pis. So we have a small application. We named it the Terminator application, which is just a simple application which is interacting with the GPIO port and discussing with the brain of Skynet. And for the moment, the brain of Skynet is mocked in a simple console instance, which is deployed on all the nodes of our platform. The idea is console is able to store everything which is gathered from our devices. And so in this metaphor, the idea is if a Terminator device detects something, it will tell it to the brain, and every other devices will be able to interact. For example, come to the target to fight it. So our brain, which is for the moment mocked with a simple console instance deployed on all the devices composing our cluster. The thing is, assuming that you destroy all data centers in the world, how we could continue to operate with our devices only. For this, we put part of the brain on the terminators, and so it means that we must use some kind of multi-architecture image, because it means that we need some console instances deployed on the traditional nodes of the cluster, on x86 architectures, but also on the ARM devices. For a long time now, from January 2016, I think, it's now possible to host on the hub various kind of images, not only for the x86 architecture. But the question is how to detect what kind of images to use. Sometimes it's not clear because it may be not pushed in the name. You can get this information as it's stored as metadata on the hub. But the thing is, it remains different images. So the problem here is we want to leverage on our cluster to tell, okay, I want to deploy a service which is made of console instances, and I want to deploy it on all the cluster, whatever the architecture it leverages on top of. So it means that I want console instances on ARM. I want also some instances deployed on the x86 virtual machines, which are on the cloud. But to do this more simply, a new feature is being delivered these days. It's named the manifest list. These are kind of meta images which contains not images it themselves, but references to the real images. So the idea will be to create something which will package virtually our images for all the architectures. For this, we use just a simple manifest tool. So for the moment, this tool is enabling to get information from the registry. So in this example, it's just gathering some information of our console image built for Raspberry Pis. We can see that the architecture is for ARM. But the idea will be to create a manifest which virtually point to the various images. For this, we created a YAML file, which is a manifest which expresses the fact that our new image, named in this example adrianblind/console.latest, it's not really an image. It doesn't contain something except the metadata. And these metadata just tell that we are two subsequent images attached to this one. The first one is a console image made for traditional AMD 64 architectures, and also a second image which is dedicated to run on ARM architectures. So the adrianblind/console image does not contain an image itself. It just contains references. And we use the manifest tool to push these metadata and create virtually this kind of mocked new image on the hub. If you check this image on the hub, you will see that it exists, but technically it does just contain this metadata to point to the existing images. And when we are using again the manifest tool to have some information related to the new kind of manifest list image we exposed in the hub, we see now that we have this image containing two manifest references. It references the two images we just saw before. And so the idea is, now if I just want to create a new service, which could be which leverage on my image, I just have to create a new service referencing the image I want to use, and telling him the number of replicas extra I want to have. And the point is, on the cluster, I will see that every node which complies to the architectures available will be started with the appropriate image. Virtually, you just see the frontal adrianblind/console imaging, but physically, beyond this, it's running the appropriate image corresponding to the appropriate architecture. If we had in this cluster some additional nodes using another architecture, it would just not run any kind of containers, because in my manifest list, I just have referenced images for ARM and AMD 64 architectures. This tool is used temporarily since Christy Perez has created already a pull request, which is reference 138, which proposed to embed natively in the Docker CLI new commands, which are Docker manifest create, annotate, push, etc., to integrate directly in Docker these features to no longer have to use this separate tool. Because the thing is, it's just about plugging this into the CLI, since the hub is already compliant with this kind of manifest list. And the hub is also able today already to host various kind of images for different architectures. So, as a conclusion. You have seen that we use some kind of projects of Docker, lots of projects of Docker, but it's all about automated things, because Infrakit is really great for provisioning and self-healing architecture and to automate the creation of the cluster. LinuxKit is awesome for immutability and to automate creation of immutable OS or images for Infrakit. We also use multi-arch images, which are great to use on a cluster with different kind of CPUs, like ARM or x86. And you see that Docker finally gets beyond the containers. It's enable automated IT and it's leveraging on DevOps principle, which is really important.
One thing we didn't speak about is distributed storage. You have seen that 1 year or 2 years ago, Docker buy a startup called infinite.sh. And there's the work in progress to have distributed storage to be possible to distribute across the cluster. So stay tuned.
Okay.
One final word, Adrian?
It's just for fun. Since we use this metaphor to express some technical stuff, the idea is just to come back last time to this metaphor. The idea is we played with small fun Raspberry Pis to do this. But just replace these funny devices by Boston Dynamics robots. So this is the ones you can see here. Add some more intelligence in the application. Today we are speaking about Law's principle for lethal autonomous weapons. So imagine that our devices will have intelligence enough to attack and defend by themselves without being controlled. Just imagine that you could completely decentralize networks, because this is another point we did not address today. The thing is, we are still relying on traditional network principles. For next versions of this talk, we expect to use some ad hoc Wi-Fi networks to make the platform completely self-sufficient without relying on something else. Add some AI, etc., etc. And finally, you may get some real terminators up and running, finally. Thank you.
Okay, so do you have some questions? Maybe? Yeah? So the question is the cluster still up and running? Yeah?
Yeah.
So
show it off.
Yeah, of course.
It's running. We
have some.
Initially,
we have one manager up and running. Yeah. Wow. Oh yeah.
Your Chaos Monkey was really accurate.
Yeah.
The demo effect.
And what's the visualizer? Yeah.
But the thing is, yes, it's running. Initially, we wanted to have the Raspberry Pis on stage with some sponsors. I have them in the bag. But the problem was to connect them to the cloud nodes, because it was necessary to expose some ports to make it running. So the Raspberry Pis are just in my flat in Paris to make it running, and the cloud nodes are obviously running also. Thank you.